Okay, today we're going to go over distance time graphs. So the main, also these distance time graphs, we might also just refer to them as speed graphs because, well, distance time, that's just speed, right? Distance divided by time, that's speed. Okay, so there's a couple things you have to do today. So the first thing you have to be able to do is you have to look at these graphs and you have to be able to calculate speed from these graphs. That's the first thing you have to do. Okay. Second thing you have to be able to do is you have to be able to interpret that R here, interpret a graph. So what do I mean by that? I mean you have to be able to explain what is a graph saying. Okay. So let's go over some basics. We'll start off very simple, then get a little bit more complex. So if we're looking at a distance time graph, it's going to look something like this. Okay, we have our time here on our x-axis, and then we have distance on our y. Okay, this is often going to be in meters, and this will be in seconds, even though that's not always the case. Okay, but it's always going to be some sort of distance over some sort of time. Okay, all right. So let's go ahead and go over the first part, which is how do we calculate speed using a graph? Okay. Well, if we look at an example, let me just draw a quick example here. So let's make a graph here. We'll just create a simple graph, and we'll go by 5. So we'll go 5, 10, 15, 20. Okay. So other side we'll do the same thing. 5, 10, 15, 20. Okay. This is going to be, this here will be my time in seconds. And on this other side here will be my distance traveled in meters. Okay, so again, this is just time, as time is running, this plots how far I am from the origin, which is the point 0. So this point here, this is 0, that's my origin, my starting point. Okay, and as I go up, I'm moving away from my origin. Okay, so let's say I travel in 10 seconds, I travel 20 meters. So in 10 seconds, I travel 20 meters away from the origin. Okay, so that we're trying to find speed, right? Well, if we notice, we know speed equals distance divided by time. Well, in a graph, actually, let me go back to here. So if we look at a graph, when we go up and down, that's what I call my rise here. Okay, so this is my rise. And when I go left to right, that's my run. Okay, so in this graph here, my distance is up and down. It's how much I'm rising on this graph. So that's so distance is the same thing as rise, and time is the same thing as my run. Okay, in other words, speed equals distance divided by time, which is rise over run. Well, rise over run in math, we just call that our slope. So most of you have probably seen this. So in other words, speed equals slope. They're equal to each other. So if I know my slope, then I know my speed because they're equal to each other. Okay, so let's do it for this problem. Well, in this problem, I know that I rose from start to finish. I rose 20, right? And the run was 10. I finished at 10. So put that in. So my rise is 20 meters. My run is 10 seconds. In other words, it's 20 divided by 10 gives us 2 meters per second. Meters per second. We can't forget those units. Okay? So that's that. That's how we calculate speed. So let's look at a little bit more complicated example, and we'll go from there. So let's say we have a graph that looks like still sort of equal proportions here. Let's go, we can go fives again. We'll go 5, 10, 15, 20, 25. Okay? We'll do the same thing over here. We'll go 5, 10, 15, 20, and 25 up here. Okay? We still have time here in seconds, and we still have distance here in meters. Distance in meters. Okay? Alright, so let's say this person they travel 10 meters in 10 seconds. So it takes them 10 seconds to travel 10 meters. So 10 seconds to travel 10 meters. And I'm starting at my starting point, right? Then they travel another 10 meters, but they do that in only 5 seconds. So they travel another 10. So they started at 10, but they're going to end at 20, right? Because they travel 10 more. Like that. Okay? So I can calculate the speed at each different point. So let's go ahead and do that now. So at this first point here, at this part of the line, well, if you notice, I rose 10. So my speed equals 10 meters divided by, my run was also 10 seconds. That's just 10 divided by 10 is 1 meter per second. Okay? But what about that second portion? What about here? Well, in this case, I got to get my rise, but my rise is not from the bottom. My rise is from where I started, which is here. So I rose, if I look at this, I started at 10, I went to 20, so I rose, my speed was 10. I only rose 10. Okay, divided by, what was my run? Well, I'm starting here and I'm going to here. So my run is only that portion right there, which would be 5. So 5 seconds. 10 divided by 5 gives me 2 meters per second. So that's my speed for that. That's my speed for that. Okay? So that's how we calculate speed. Now let's go over so that's the more difficult part. Now let's go over the easier part. How do we interpret graphs? How do we look at them and know what they're saying? So the first thing is, if you notice, whenever we have a higher slope, in other words, it goes higher up, it's going to be faster. Okay, so that's the first thing that we should notice. So let's go ahead and write that down. So let's talk about slope here. Okay, so when I have a graph here in which I have time here and I have distance here, I'll just abbreviate. Okay, if we have something that looks like this and we have something that looks like this, the one with the higher slope, that's going to be the one that is traveling faster. Okay? So, some questions are going to ask, in which portion is the person traveling faster? You don't have to always calculate it. We could just look at the slope, and that will tell us which one is faster and which one is slower. Okay? Alright, next thing. What if we have something that looks like this? So, we still have a distance. We still have distance here. Time here. Let's say this is 5 seconds here. Let's say 5 meters. Let's say a person travels a certain time, but then we see a straight line. So what does a straight line mean? All that means is that individual stayed at 5 meters. So in other words, if you're staying in the same spot, then you are not moving. Okay, so a straight line like that with no slope, that just means, no slope just means we are not moving. In other words, my speed or my velocity is 0, meters per second. Okay? That's all that means. Last of all, what if you see a negative slope? A negative slope. So you might see something like that, right? Where it is negative. Well, if this is my origin, right? That's my origin. If I'm moving away from it and have a positive slope, then if I'm going negative, all it means is I'm going back to my origin, because I'm going back to the original spot, which was 0, which is where I started. So negative slopes, all they mean is back to origin. Okay, so if you ever see something, if you ever calculate the slope and you get like for example, like negative 5 meters per second, okay, that's possible. All that means, the negative, that just tells you that you're moving backwards rather than forward. Okay, and that's pretty much it for that. We will do one example as a class.